Today we're going over Notes 2.1, analyzing piecewise functions. So again, we ended with this in Unit 1. Again, piecewise functions are functions that are made up of different types of functions. So first off, an increasing function. An increasing function is when the y value increases as the x value increases. So this would be an increasing function. This would be an increasing function. A decreasing function is when the y value decreases as the x value increases. So this is a decreasing function. This is a decreasing function. Those are examples of increasing and decreasing. So example 1, state where it's increasing and the interval where it's decreasing. So we're going to talk about open intervals. So you're going to see that we're going to use the parentheses a lot. Right? This is what we call an open interval. So from 2 to 3, right, this part here, so from 2 to 3, it would be decreasing. And then from 3 on, 3 to infinity, it would be increasing. And all we're doing is we're looking at the x values. So from -5 to 2, that is what we would call constant. Again, we're going to use the parentheses, which again, you're going to see the phrase open interval. Right, a relative max is where it's increasing before the x value and decreasing after. And so, for example, this point here would be a relative max. So this point here would be a relative max. A relative min is it's decreasing before the x value and increasing after. So here, the red dot would be a relative min. Here, the red dot would be a relative min. Up here, if you look up at the graph, at the point 30, that would be a relative minimum. If you look at the point 23 right here, that is not a relative maximum because there's not what we call a change in direction. It's not increasing, then decreasing. There has to be that change from increasing to decreasing, increasing to decreasing. There has to be a change in the direction to have a relative max or relative min. So example 2, state the coordinates of any relative mins or maxes. So change in direction, change in direction. So I'm going to have a maximum at the point 1, 4. I'm going to have a minimum at the point 2, -2. These are not open intervals. These are coordinates. Maximum and minimums are points. They're going to have the same notation as open and or as increasing and decreasing. So they have the same notation, so you have to be careful with that. Because you could see these symbols and they can mean multiple different things. Right? This could be an ordered pair, a coordinate, a point, or it could be an interval. So you got to be careful with that. All right, go ahead, flip your notes over. So example 3, we want to state any open intervals, so that means we're going to use parentheses, right? Anytime you see the phrase open interval. So where f is increasing, f is this black graph here. So it's decreasing, increasing, decreasing, increasing. So it's increasing at 2 different parts. So we're going to have multiple intervals. So first from -2 to 0, right? From here to here. And then from 3 to 5. So we're going to have a union because, again, we're skipping numbers. And when I ask you where is it increasing, decreasing, we're just looking at the x values. Right? Looking left to right. Okay, where is it decreasing? Well, again, it's decreasing here and here. So it's decreasing from -5 to -3. Skipping all the way to 0. To 3. Okay, domain. Right? Now, domain is different that you can't have. We're going back to what we learned domains in the first unit. So it starts at -5. No breaks all the way to 5. And again, solid points. You can touch it, so it's squared closed brackets. Okay, the range, the lowest it gets to is here, the highest it gets to is here. -3 to 3. And again, domain and range can have square brackets because you could include the point or not include the point. Okay, relative mins and relative max. So remember, there has to be a change in direction. So decreasing, increasing. So that would be a relative minimum. So -3, 0. Decreasing, increasing. So that would be a relative minimum. 3, -3. Now, I don't put a union. These are ordered pairs. They're 2 points, so I could put a comma. It's not like A where it's an interval. The parentheses here in D represent 2 points. So you don't put a union. Okay, and then the last one, E, right? We have increasing, decreasing. So we have the maximum at 0, 3. Wait, the last part, what we're going to do is write the piecewise function. What's the equation that represents this? So first off, we got to figure, well, how many parts? Well, it looks like there might be 2 absolute value, but if they're absolute value, they have the same slope coming in and going out. So this would be one function. This, let's do a different color. This would be one function. Right? Now, is this the same function? Does it have the same slope? Well, we got to figure that out. So what's the slope from here to here? Right? Down 2 over 1. And the slope from here to here is 2 over 2. So those are 2 different functions. So we're going to have one function that's a line, and then we're going to have another function that's a line. So when we go to write our equation here, so f of x equals, we're going to have 1, 2, 3 functions. And then we're going to restrict the domain. Okay. So first one, right, here I'm highlighting black as absolute value. It's been shifted from the origin. So x plus 3, and has not been shifted up. And then we need its slope. So up 1 over 1. So +1. Okay. So then next, we have from this function is a line. So it's been shifted, we'll say up 3. So we have x plus 3. And now we just need the slope, which we figured out already. Right, 2 over 1, so -2x. And then the last part, right, is figuring out this line here. So pick one of the points. So let's say that point. So it's been shifted to the right 5 and down 1, and the slope is +1. So that's the general form. Now we got to figure out, okay, where are our boundary lines? Well, the one function starts here and ends here. Okay, so that's from -5 to 0. The next function starts at 0 and goes to 3. So this is from 0 to 3. And then the next function goes from 3 to 5. So from 3 to 5. And notice it's the same symbol. Right? Now, how do I know if I'm going to have the little bar underneath? Well, is it an open or closed dot? That's how I determine. But again, it's the same looking notation, because this is what we call a compound inequality. X is less than this number and greater than that number. So it's 2 inequalities in one. But it's always the same thing. They're 2, and the notation always looks like this. It's always x, and then the two less than symbols. But this reads x is less than 3 and greater than -5. It's both of them. So you got to be careful with that notation, because that's where some students mess up. Okay, so that's writing the function. So the easiest way to do it is to focus on one piece by one piece. If you want to do the domain restrictions as you go, you can. Sometimes I do at the beginning, sometimes I do at the end. It's probably one of the easier parts to do. The writing the equations the toughest part. Example 4, so same idea. Open intervals where it's increasing. So it's increasing right here, and it keeps on increasing. So it starts at -2 and keeps going all the way to 5. It's decreasing from -infinity all the way to -2. And if it wanted to, it could say, where is it constant? That would be from 5 to 8. All right, domain starts all the way from infinity. Now, when you get to 0 here, right, there's a break here, but it's filled in up here, so that's continuous. And same thing, so it goes all the way to 8, and it's an open dot, so it's a parenthesis. The range starts, the lowest is -2, and it keeps going up forever. There we go. Right, relative minimums. That means there has to be a change in direction. Oh, there's a change in direction down there, so it would be -2, -2. Nowhere else. Maximum. Again, the point here that I'm circling up there is not a maximum because it doesn't change. It's not increasing then decreasing. There has to be that change in direction. So this would be, there wouldn't be any. Wait, last part to this is writing the function. So there is one function, two functions, three functions. So there's three functions here. So we have f of x equals, and we get the fancy curly bracket, 1, 2, 3. So we're going to have to restrict the domain, 1, 2, 3. So we could do the domain restrictions this time. So you have one boundary line, two boundary lines, three boundary lines. So the first function goes from -infinity right? So it's going to be x is less than 0. And that's it, right? All right. The next one's going to be x is less or greater than or equal to 0, but less than 5. And then the last one is x is less than 8, but greater than or equal to 5. Now you notice here I wrote less than 5 because if you look at the dot for that function at 5, it's an open dot. And why does this have the bar underneath? Because at 5 for that linear function, it's a closed dot. Closed dot is going to have the equal bar underneath. Open dot is not going to have the equal bar. So now we got to write the three functions. So let's do the two linear functions. So the linear function here in red, right? So it's been shifted up 3, so x plus 3. And the slope is up 1 over 2. So it's 1/2. Okay, the next is a horizontal line. Right? So that horizontal line goes from here to here, so it's just 3, right? Slope of 0, so we're good. So now we have the quadratic. Okay, so think about the quadratic. The general form is a and then x minus h squared plus k. So the shift from the origin, it's been shifted to the left 2 and down 2. Right, that's where it is. So now we need to figure out what a is. Okay, so we could choose another point and plug it in. Or, we can think back to our pattern, kind of use some knowledge. Remember our pattern for parabolas, 1a, 3a, 5a. So you go over 1 and up. Whatever you go up is a. So if you go here over 1, look at that, we went up 1. So in this case, a is actually positive 1. If you went over and then you went up 2, that's what a would be. If you went over 1 and up 4, that's what a would be. This is always 1. So anytime you're doing this to kind of save some algebra, right, we still remember the pattern, 1a, 3a, 5a. You go to your parabola. You start at the vertex. You go right 1 or left, whatever, and you go up or down. As soon as you touch the curve, at whatever distance that is a. Now this works because it's a whole number. Sometimes that's not going to, it's going to still work, but it's going to be hard to tell because it could be a fraction. In this case, it's not. So there's your equation. So again, we went through, we did the boundary lines, right? One boundary line at 0, one boundary line at 5, one boundary line at 8. Right? That's how we did the domain restrictions, and then we went back and wrote the part of the functions. Please make sure when you're doing your summary, you answer your essential questions.